Hello everyone. In this video, we'll see how to guarantee message integrity. What is message integrity? Integrity means it is not changed in the middle. All right. So let's say A is sending some file, some message to B. A is sending a message to B through some path. Through some path, they are sending messages. Now, how can B ensure that whatever A is saying is reaching him perfectly? Let's say A is sending the number 1011, and what if B receives the number to be 1012? Can happen, right? These are all at the end of the day, these are bits, and some bits can flip. So how to solve this? We solve this by using something called a message and a digest. So what is a digest in the first place? Digest is a compressed form of the message which is not useful by itself, but it is used to verify the integrity of the message. Let's say we have a message 10115, or let's say the message to be hello world. So this is the message, okay, and the digest will be something like ABCD. This is much smaller than the original message. What you can do is you can follow some algorithm which will generate this digest, and when sending it to B, you can send the message and you can send the digest. Okay, now what B will do is, this is A and this is B. Now what B will do is B will follow the same algorithm, and he will also calculate this digest. He will also calculate this digest, and if the digest matches, then the message is accepted. If the digest does not match, then the message is rejected. All right. So in the real world, this digest is generated by hashing algorithms. Few examples are MD5, SHA 512, etc. Right? These are all hashing algorithms. We are not going to study these algorithms, but we'll see how they are used in practice. All right. So let's do something. Let's create a text file. We'll create a text file and we'll name it message. All right. So now we open the text file and we send a message. The secret number is 234567890. All right. Now what we do is we are sending a secret number and we're sending it to someone. Now what we do is we should guarantee that this secret number is unmodified, right? Let's say if someone modifies this secret number 2 to something else. Let's say someone is modifying the secret number to 1. So we will not know that how this happened, right? So will the same messages will look the same from the outside, and we'll just send the message. So what we do is we generate something called a hash or a digest. What is a digest? Let's see how it is generated. In Windows, what you do is you open PowerShell and you say certutil and you say hash file, then you give it the file. You give it the file and you say MD5 or whatever hashing algorithm you want. All right. So this is the hash. Now what you do is you copy this and you put it in a separate file called digest.md5. Yeah, you actually need to rename this file to this file.md5. Okay, in Windows you have to rename it a different way, I guess. Yeah, this MD5 file is called a digest. This is the digest of the message. Now this is the message and this is the digest of the message. You send both of them together. Now what you do is, this message is fine, right? So this secret number is 123456, and whenever the guy receives it, he will also run the hashing algorithm and check. MD5. Yeah, the hashes match, and so everything is fine. This hash is stored in this digest file, right? Now, if this message is modified, let's say we're modifying it to 1, and now if we are trying to calculate the same hash, now the hash is totally different, right? This is totally different than this. So now we cannot guarantee. Now we know that this message has been modified. So that's the use of digest and hash files. I hope you understood the use of message and MD5 and digest and hash files. That's it for this video. I'll see you in the next one.